Here's problem 25(8). Point charges little q and big Q are positioned as shown. Little q is plus 2 nanocoulombs, big Q is minus 2 nanocoulombs. Distance A is 3 meters, B is 4 meters. What is the electric potential difference, VA minus VB? Since we're dealing with scalar values, we just want to find the scalar potential at A and the scalar potential at B and subtract the two. So let's do that, and we add up the contributions from little q and big Q respectively. Little q is a positive charge equal to 2 nanocoulombs, and big Q is a negative charge equal to negative 2 nanocoulombs. And we're told that distance A is 3 meters, B is 4 meters, and this would be A over here as well. So if we're looking at that, then we would be able to calculate that the distance from big Q to point A is going to be 5 meters. And for that matter, distance from little q to point B is also going to be 5 meters because we have ourselves a 3, 4, 5 triangle in either case. Alright, so here's point A and here's point B over here. If we look for the potential at point A, that's going to be K little q over R1 plus K big Q over R2. So that is going to be 9 times 10 to the 9. Little q is 2 nanocoulombs, 2 times 10 to the minus 9, and is located 3 meters away. And then we have big Q, which is minus 2 nanocoulombs, and that's located 5 meters away. As we multiply the 10 to the 9 through, that's going to multiply through with the 10 to the minus 9, so those cancel out. And this would be equal to 9 times 2/3 minus 2/5, which would be 9 times 10/15 minus 6/15, 9 times 4/15, which would be 36/15, or 2.4 volts. So that is the potential at A, 2.4 volts. Let's do the same thing for B. Potential at B is equal to KQ over R1 plus KQ big Q over R2, and that's going to be equal to 9 times 10 to the 9. Little q is 2 nanocoulombs, 2 times 10 to the minus 9. In this case, it's located 5 meters away, plus big Q, which is minus 2 nanocoulombs, and that's located only 3 meters away. Again, multiplying the 10 to the 9s through gets rid of the 10 to the minus 9s, and this would be equal to 9 times 2/5 minus 2/3, which would be 9 times 6/15 minus 10/15, or 9 times a negative 4/15, which would be a negative 36/15, or a negative 2.4 volts. So that's the potential at B, a negative 2.4 volts. We want to find the potential at A minus the potential at B. So that is going to be 2.4 volts minus a negative 2.4 volts. And that will be 4.8 volts as we add these two together. So the potential difference, VA minus VB, is 4.8 volts. Answer.